Hi, welcome to Easy Maths for Everyone. In today's video, I am going to start with the chapter Coordinate Geometry for Class 10. In my previous video, I have shared about some previous knowledge that would be needed for this lesson. If you haven't watched that video yet, please do watch that before this video for better understanding. The link is given in the description box. Let's get started with today's lesson. The topics that are to be covered in this lecture will be the distance formula, deriving the distance formula, and some example sums using the distance formula. Suppose if we have 2 points x1, y1 and x2, y2 in the coordinate plane and we would like to find the distance between these 2 points. How are we going to do this? In order to find the distance between these 2 points x1, y1 and x2, y2, we may need to do some construction over here. Let us draw two perpendicular lines from the points x1, y1 and x2, y2 to the x-axis and a horizontal line from x1, y1 to meet this line over here. Since there are so many points over here, let us name them to make our job easy. The point x1, y1 I have named as A and the point x2, y2 is named as B. And the perpendicular lines which we drew from A and B are named as AL and BM. And the horizontal line which I drew from A to BM is named as AN. Let us take this distance between A and B to be D, which we are going to find now. Now, the distance between A and N is the same as the distance between L and M. How are we going to find the distance between L and M? The distance between O and L is x1 and the distance between O and M is x2. So, the distance between L and M is OM minus OL, which is equal to x2 minus x1. And similarly, the distance between B and N can be found by finding the distance between Q and P, which is equal to OQ minus OP, which is equal to Y2 minus Y1. Now consider the triangle BAN over here, in which AN is perpendicular to BN. So obviously the triangle BAN is a right angled triangle in which AN and BN are called the legs of the triangle and the distance D, the AB line, is the hypotenuse of the triangle. So the length which we would like to find is the length of the hypotenuse of the triangle BAN. How are we going to find the length of the hypotenuse of this triangle? We may need the help of the famous Pythagoras theorem to solve this. Let me remind you about the Pythagoras theorem here. If we have a right angle triangle like this, in which A and B are the legs of the triangle and C is the hypotenuse of the triangle, then this triangle obeys this rule. That is, A square plus B square is always equal to C square. This is the rule which we are going to use in this triangle also to find the length of the hypotenuse of the triangle BAN. Using the Pythagoras theorem here to find the distance D, we will be getting D square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So, here comes the distance formula. Finding the square root on both sides, we will get D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now, let us try finding the distance between two given points using some example sums. We will understand this concept more clear by seeing some examples. Let us take this sum as an example. So we would like to find the distance between the points P and Q. So let us call the distance between these 2 points as PQ. Then the distance between P and Q can be found using the distance formula, which says D equal to x2 minus x1 whole square plus y2 minus y1 whole square. Using this formula, let us name these points as x1, y1 and x2, y2. Let us call this point P as x1, y1 and let us call this point Q as x2, y2. Then the distance between P and Q can be found by using the formula x2 minus x1. What is our x2 here? It is 2 minus x1 is already having another minus. So put it in a bracket. This one whole square plus y2 is minus 5 in this minus y1 is 7 upon that a square. So this is equal to square root of 2 minus of minus 4 will be 2 plus 4 whole square plus minus 5 minus 7 will be minus 12 whole square, which is equal to root of 6 square plus minus 12 whole square, which is equal to root of 36 plus minus 12 whole square will be positive 144, and the sum of these two will be equal to 6 plus 4 is 10, balance 1, 4 plus 3 is 7, 7 plus 1 is 8 and root of 180. Let's take another example. Find the distance between the point 6, minus 6 and the origin. Okay, origin means it is 0, 0. So, as we did in the previous sum, let us name these points as x1, y1 and x2, y2. We are going to find the distance between these 2 points. So, D is equal to square root of x2 minus x1, that is 0 minus 6 the whole square plus 0 y2 minus y1 whole square will be 0 minus of minus 6 the whole square. So this is equal to 0 minus 6 will be minus 6 whole square plus 0 minus of minus 6 will be 6 whole square. This is equal to minus 6 the whole square will be positive 36 and 6 square is again positive 36. So 36 plus 36 will be equal to 72, which can be further reduced as root of 36 multiplied by 2, and this 36 comes out of the root as 6 and root 2 stays inside the root. So the distance D is 6 root 2 units. Suppose if the points lie on a horizontal line or a vertical line like this, for example, if I have 2 points which are 5, 2 and 13, 2, and I want to find the distance between these 2 points, is it necessary to use the distance formula? No, right? Because since this is a horizontal line, the distance between 5, 2 and 13, 2 will be the difference between 13 and 5, which is 8 units. And similarly, for this vertical line, which is connecting 3, 4 and 11, 4, we don't need to use the distance formula here also, because the distance between these 2 points will be just the difference between 11 and 3, which is again 8 units. That's all for today's lecture. Let us continue with the rest in our next video. If you like today's lecture, please give us a thumbs up and do share it with your friends and relatives, and give me your feedback in the comment section below. Do subscribe our channel in order not to miss our future upcoming videos. Thank you for watching. Bye.